Okay, let's roll through some examples of condensing logarithmic expressions into a single logarithm with leading coefficient of 1, positive 1. This really is a pretty quick and easy process as long as we remember our 3 rules. All right. On each one of these, you want to basically start out and make sure you have the exact same base for each logarithmic function as you combine them together. So on this first one, notice they're both log base b's. We can go ahead and combine these together. Because the first one is positive out in front, that's going to work out that in a single logarithmic function, it's going to be log base b, same log with same base. Positive in front means the 28 goes in the numerator, and the 7 is negative out in front here, so that means that the 7 goes in the denominator. A little bit of simplifying down, we're going to get log base b, 28 over 7 makes 4. All right, next one we have 1/3 times the natural log of 8. So to get started on this, we notice we have a 1/3 out in front. It's not a 1 out in front, so we're going to use our exponent rule that says that 1/3 can come up and be the exponent attached to that 8. So we start out and we're going to go natural log of 8 raised to the 1/3 power. You may recall that this means the same thing as natural log of the cube root of 8. That 1/3 power expressed as a radical will be 1 as an exponent and 3 as the index on the radical. So a little bit of reducing down here, the cube root of 8 works out to be 2. So that's going to be our solution. Moving down here, the next thing we have is we have a positive natural log here and a negative natural log. So as we combine these together, make sure that the positive out in front is going to go up in the numerator. The negative out in front goes down to the denominator. And then it's just a matter of a little bit of simple reducing. All right, 6 divided by 3 makes 2. And x to the 9th power divided by x to the 2nd power, there are more x's up in the numerator, and there are 7 more. So that's going to give you x to the 7th power. Next up, we have log of 2x to the 4th plus log of 3x to the 5th. In this case, they're both positive, so as we combine them together, we're going to get log. The 2x to the 4th goes in the numerator because it's positive, and it gets multiplied by 3x to the 5th power. Again, both go in the numerator because both were positive out in front. The simplifying down we can do here is we can go log, common log of, go ahead and multiply our constants together, right? 2 times 3 makes 6. And then our x's, we have x to the 4th multiplied by x to the 5th. So that's a total of 9 x's being multiplied together. So we'll use x to the 9th power going on here. Next up, let's try another one with natural logs across the board. Shouldn't be too bad to combine them into a single natural log. And we could do this all in one step, or we could do it as multiple different steps, right? We could combine the first 2 natural logs together, bring along the 3rd one, and then work it in as a separate step. But I like doing these all at once if I can, right? It's positive 1 out here, so the 7 goes in the numerator. Positive here, x goes in the numerator. Positive here, y goes in the numerator, and we're done. All right, this one, we have positives and negatives, but very similar, right? We're going to go natural log, single natural log, positive here, so the a goes in the numerator, negative for our second part, so the d goes in the denominator, negative here, c goes in the denominator. I'll clean this up and make it look a little bit nicer, but there we have it, a over dc on the inside of our natural log. Let's try this one a little bit. More going on here, but they're all log base 3s, so this should be pretty efficient. We'll get a log base 3. It looks to me like they're all positives, so they're all going to go up in the numerator. So 2 in the numerator over 1 if you'd like, multiplied by a, multiplied by 11, multiplied by b. This will clean up a little bit that instead of leaving a 2 times 11 on the inside, let's go ahead and make that 22. AB, and we got our solution. All right, last one on this video. What happens if we have a negative out in front? Well, You can think of this as being -1 multiplied by our log base b of 1 over 7. What we can do is we can take that multiple that's not a positive one, move it up to the exponent first. So what that would look like would be log base b of 1/7, all raised to the -1st power. Just a little bit confusing. We would next probably want to go ahead and bring this to the inside by multiplying each one of those exponents by -1. Now you may have learned this as a little bit slightly different looking rule. What's going to end up happening is we're going to get 1 to the -1st, 7 to the -1st going on here because they each initially had a positive 1 as their exponent. And to clean this up at the end, it works out to make an exponent positive. You're going to switch places, basically kind of go from numerator to denominator. So that 1 can go down to the denominator. We can make it a positive 1 for its exponent. The 7 can go from denominator to numerator. You'll note that this is really just flipping that fraction upside down where we had 1 over 7. It's going to become 7 over 1. Or, in our case, log base b of 7 over 1 makes 7. All right. If you'd learn this a slightly different way where this -1 or the -1 up here in the exponent simply flips this fraction upside down, we will get to this exact same solution. So I hope this helps out as you're working on combining logarithmic functions, multiple logarithms together into a single logarithmic function. Good luck.